Welcome back, everyone. This is Class 13, recorded while I'm out of town, so treat it like a normal session, take notes, and pause the video whenever you need to. Today we're in Division 08, and specifically doors, frames, handling, and hardware. I'll be honest with you up front. This is one of the most vocabulary-heavy days in the whole course. There are a lot of terms, a lot of types, and a few measurements that have to be exactly right or the door doesn't work. But here's why it's worth the effort. Doors and hardware are where a building meets the people using it every single day. They're life safety elements, they're security elements, they're accessibility elements, and they get touched thousands of times. As a project engineer, you'll be checking door schedules, verifying handing before hardware gets ordered, and coordinating the door, the frame, and the hardware so they all match. Get one of those wrong, and you've got expensive field rework. We'll cover door types and how to select them, then frames and the all-important throat size, then door handing, left hand, right hand, and the reverses, then back set, then door prep and hardware coordination, and finally the 8 hardware types. Lots to do, so let's get into it. Here's the roadmap, and it's a full one. Block 1, door types, materials, and typical applications. Block 2, frame types and construction. Block 3, commercial versus residential door systems, the key differences. Block 4, door handing, the 4 hands of door operation. Block 5, rough opening and frame sizing. Block 6, back set, the critical measurement for hardware fit. Block 7, door hardware, the common components of a door system. And Block 8, participation assignment 13. A couple of things to flag right now because they're the make or break details. See Block 2. The throat size is the distance from the stop, the back of the frame, to the exterior face of the wall. The frame's throat has to match the wall thickness. Get that wrong, and the frame literally doesn't fit the wall. And Block 4, door handing. There are 4 hands: left hand, right hand, left hand reverse, and right hand reverse. The rule, which we'll drill until it's automatic, is at the bottom of that block. Stand on the exterior side. If the hinges are on the left, it's left hand. If they're on the right, it's right hand. We'll come back to this. The bottom of the slide sums up the day's attitude. Good doors, right fit, safe buildings, and always verify field conditions, because field conditions vary. Measure twice, install once. 6 common door types. Learn each by its material, where it's used, and one defining note. Hollow metal is steel-faced over a steel frame, welded or bolted construction. You'll find it in schools, hospitals, corridors, and utility rooms, anywhere durability, security, and fire rating matter. Typical sizes you'll see commonly are 3 foot, 0 by 7 foot, 0 and 3 foot, 0 by 8 foot 0. This is the workhorse commercial door. Wood flush doors are solid core or hollow core wood construction, common for offices, classrooms, and hospitality interiors. A typical commercial wood door thickness is 1 3/4 inches. Remember that number. Solid core for sound and durability, hollow core for lighter, lower-cost interior use. Aluminum and glass doors are aluminum narrow dash, medium dash, or wide-style frames with glazed infill. The style is the width of the vertical frame member, and that width is a real spec choice. Used at storefronts, vestibules, and building entrances. Important note: tempered or safety glazing is required, because these are glass doors people walk through. FRP is fiberglass reinforced plastic panels and frames. Used in food processing, labs, washdown, and humid environments. The defining note: it's corrosion and moisture resistant, which is exactly why you'd choose it over hollow metal in a wet or chemical environment where steel would rust. Overhead doors are sectional, coiling, or rolling steel door systems, used at loading docks, garages, and service bays. They can be manual or motor-operated and are sized to the opening and use. Different animal from a swing door. These are about moving vehicles and material. Sliding and bifold are pocket, bypass, or bifold door systems, usually interior or specialty applications where you're saving space. Note that they have more limited commercial hardware and fire rating applications, so they're not your go-to where rating or security matters. The icon strip ties it together. Durability, fire and code, moisture resistance, and security are the four lenses you select through. And the instructor note is the rule for the whole slide. Match the door type to the occupancy, the traffic level, the code requirements, and the exposure conditions. There's no universally best door, only the right door for the situation. This slide is a reference matrix, so I won't read every cell. You can study the table on your own. Instead, let me teach you how to use it. The columns rate each door type on durability, fire-rated availability, moisture resistance, security, and typical commercial use. Scan across any row and you get that door's profile. The quick rules of thumb at the bottom are what I want you to remember. Choose hollow metal for durability and security. Choose wood flush for interior aesthetics and acoustics. Choose aluminum and glass for visibility, natural light, and modern storefronts. Choose FRP for harsh, wet, or chemical areas. Choose overhead for large openings and loading operations. And choose sliding or bifold for space-saving or partition needs. And on the right are the 5 selection factors that drive every door decision. 1. Occupancy and use. Match the door to the building function and the user needs, whether that's aesthetics, visibility, or hygiene. 2. Traffic level. Higher traffic areas need more durable doors and hardware. 3. Exposure to moisture or chemicals. Select materials with adequate corrosion and moisture resistance. 4. Required fire rating. Confirm whether code requires a fire-rated door for that location and opening. 5. Security and access control. Consider the need for security hardware and impact resistance. The note at the bottom is non-negotiable. Always verify code requirements, IBC, and FPA 80 for fire doors, ADA for accessibility, wind load, and the manufacturer listings before final selection. Now frames, and the single most important frame concept, throat size. Start top left with the anatomy of a hollow metal frame. The head is the top horizontal member. The jamb is the vertical member. The face is the part you see flat against the wall. The stop is the projection the door closes against. The rabbet is the recess the door sits into when closed. The return is the part that wraps back flush to the wall face. And the throat. The throat is the clear distance between the two stops, and it must match the wall thickness. Here's the warning. The wrong throat size means the frame doesn't fit. You get gaps at the reveals, or the frame can't be installed at all. So how do you get it right? Look at the top right panel, wall assemblies, and throat matching. For a 3 5/8 inch stud wall with 5/8 drywall on both sides, the throat is about 4 5/8 inches. For a 6-inch stud wall with drywall both sides, the throat is about 6 5/8 inches. And for a CMU, concrete masonry unit, wall, the throat is about 8 5/8 inches. See the pattern? The throat equals the total wall thickness, drywall and all. And the note says it. Verify the exact frame spec from the architectural drawings and the wall type schedule. Bottom left, installation quality, 3 words, plumb, level, and square. Plumb means vertically true. Level means horizontally true. Square means the corners are a true 90 degrees. Why care? Because poor alignment causes door binding, latch problems, and hardware misalignment. A frame that's out of plumb gives you a door that swings open or closed on its own and a latch that won't catch. Bottom right, the 4 common frame profiles. Knockdown, or KD, frame ship flat and assemble on site. Used in masonry or existing conditions. Welded frames are one-piece welded construction, used in new stud-framed walls. Slip-on drywall frames slide over a finished drywall edge, used in finished partition systems. And the wood buck is a rough opening receiver in masonry or concrete. For anchorage in masonry, you anchor frames with wire ties or T-anchors into the mortar joints, and CMU cores may be grouted around the frame legs. The key field instruction: brace frames during masonry work so they don't shift while the wall goes up. The 4 takeaways at the bottom. Correct throat equals proper fit. Check field conditions, match the wall assembly, and verify before grouting or patching. This slide reinforces the frame material, so I'll move efficiently and highlight what's new. Panel 1 repeats the 4 frame types: KD, welded, slip-on drywall, and wood buck, with their best uses, so use it as your reference. Panel 2 is your throat quick reference, and it adds the actual wall thicknesses. A 3 5/8 stud wall with 5/8 gyp both sides is about 4.5 inches actual, taking a 4 5/8 throat. A 6-inch stud wall is about 6.5 inches actual, taking a 6 5/8 throat. A CMU wall is about 8 inches, taking an 8 5/8 throat. Same logic as before. Throat tracks total wall thickness, and the note reminds you actual dimensions vary by materials and tolerances, so verify from the drawings and wall type schedule. Panel 3, the 5 field checks before installation. Verify the rough opening size. Confirm wall thickness against the selected frame throat. Check plumb level and square and shim as needed. Verify anchors and masonry conditions, and confirm hardware prep and handing before grouting or closing in. And panel 4 shows what goes wrong if you skip those checks. A frame too tight won't fit the wall. A frame too deep gives gaps at the reveals. Out of plumb means the door binds. Out of square means latch and clearance problems. Poor anchorage means the frame shifts and cracks. The bottom line: measure the actual field condition, not assumptions, and check before grouting or patching. This is the slide. If you remember one thing from today, make it this: door handing. And before anything else, read the rule at the top with me. Stand on the outside, the key side, the pull side, facing the door. The hinge side determines left hand or right hand. And if the door swings toward you, it's a reverse. Stand outside, look at the hinges, note the swing. That's the whole method. Left hand LH. You're standing on the exterior. The hinges are on the left. The door swings away from you, into the room. That's a left-hand door, and it's the most common single-entry configuration you'll encounter. Right hand RH. Standing outside. The hinges are on the right. The door swings away from you into the room. That's right hand, the mirror image of left hand. Left hand reverse, LCHAR. Standing outside. The hinges are on the left, but now the door swings toward you, out of the room toward where you're standing. Reverse means the door swings toward the observer. So left hinges plus a toward you swing equals left hand reverse. And right hand reverse, RHR. Hinges on the right, door swings toward you. The mirror image of LCHAR. Here's your memory tip, and it's the key that unlocks all 4. Reverse means the door swings toward you. Non-reverse means it swings away from you. So the procedure every time is: stand outside, find the hinges, left or right gives you the first word, then check the swing. Away is normal, toward is reverse. And why does this matter so much? Door handing affects hardware selection, closers, lock sets, and frame prep. Order the wrong hand, and the hardware physically won't work on that door. This is the #1 source of door rework on a job, and it's completely preventable if you just apply the rule. Let's lock in handing with this field guide. Panel 1 is the step-by-step method, and it's the same rule broken into 4 steps. Step 1, stand on the key side, the pull side, facing the door. You're on the exterior. Step 2, locate the hinges. Left side is left hand, right side is right hand. Step 3, note the swing direction. Away from you is standard, toward you is reverse. Step 4, combine the hinge side and swing direction to name the hand. Their worked example: hinges left plus swings away equals LH. Exactly. Panel 2, the decision matrix, is the fastest way to get this automatic, so let's drill it. 2 questions: which side are the hinges on, and which way does it swing? Hinges on the left, swings away from you, left hand. Hinges on the right, swings away, right hand. Hinges on the left, swings toward you, left hand reverse. Hinges on the right, swings toward you, right hand reverse. Pause the video and quiz yourself on that grid until you can fill it in from memory. It will be on test 4. Panel 3, where it matters: hinges, lock sets, and lever orientation, closers and their arm configuration, hinge prep and strike prep on the frame, and overall coordination so the door, frame, and hardware schedule all align. Panel 4. The common mistakes to avoid. Standing on the wrong side of the door, confusing swing direction with hinge side, forgetting that reverse means it swings toward the observer, and failing to verify the manufacturer or hardware schedule conventions. The best practice: always verify handing on the plans, door schedules, and hardware sets before ordering or installation. And the memory shortcut one more time: reverse equals toward you. Next critical measurement: backset. The definition: top left. Backset is the distance from the door edge, the latch edge, to the center line of the borehole or lock set. In plain terms, when they drill the big hole for the doorknob or lever, the backset is how far in from the edge of the door that hole's center sits. Look at the diagram. The latch edge is the edge of the door where the latch sticks out. The backset is measured from that edge horizontally to the center line of the cylindrical lock set. That's it. One straight horizontal measurement, but it has to be exact. Here are the standard backsets you need to memorize. 2 3/8 inches is the common residential backset. 2 3/4 inches is the standard commercial backset. And 5 inches is for specialty, large style, or some aluminum storefront applications. So residential 2 3/8, commercial 2 3/4, storefront 5. Those three numbers are worth knowing cold. Why it matters: factory door preparation is cut to a specified backset. The holes are drilled at the factory based on the backset you specified. So the wrong backset causes field rework, misfit hardware, and operational issues, and it hits the schedule, the cost, and the overall door coordination. Your best practice: field verification. Verify the backset on the door schedule. Verify the hardware set and manufacturer documentation. Verify the frame and door preps match, lock and hinges, and confirm the backset before ordering hardware and doors. The bottom line in 3 icons: accurate measurement, hardware fit, and verify before ordering. A door with the wrong backset is a door you can't install the lock on. Now door prep. The cutouts and reinforcements that have to be machined into the door and frame so the hardware fits. These are done at the factory based on the schedule, which is why coordination matters so much. The common prep types: hinge prep, mortised cutouts in the door edge and frame for the hinges. The size and quantity depend on the door weight and use. Lock prep, cylindrical or mortise lock preparation in the face and edge of the door. The backset and hardware function must match the schedule, tying right back to the last slide. Closer prep, reinforcement, and mounting prep in the top rail or frame head for a surface closer or concealed closer. Viewer or peephole prep, a small bore for an optical viewer, typical in hotels and residential, uncommon in standard commercial interiors. And glass light prep, a cutout in the door face for a vision light or glazing kit, where the size, location, and fire rating limits must be coordinated. The coordination checklist pulls today together. Verify handing before finalizing hinge and lock prep. Confirm lock type, function, and backset. Match the frame prep to the door prep and hardware set. Check closer mounting side and reinforcement requirements. Coordinate glass light size with code and fire rating limits. And review the door schedule, frame schedule, and hardware set together. All three as one. And the common coordination issues are exactly the failures of that list: wrong handing, incorrect backset, hinge count mismatch, missing closer reinforcement, and field rework due to an unverified schedule. The 3 takeaways: match the schedule, verify before fabrication, and coordinate the door plus frame plus hardware as a set, because alignment prevents rework and keeps the project on schedule. Now the hardware itself. 8 types. The right hardware makes a door secure, functional, and code compliant. Let's go through all 8. A passage set is a lever or knob that latches but has no locking function. Used on interior doors that don't require security, hallways, closets, open office entries. Lever is preferred for ADA compliance because a lever can be operated without grasping or twisting. Best for low security areas with frequent traffic. A privacy set latches and locks from the inside, typically a push button or turn button on the interior side, with an emergency override, a coin turn or small screwdriver slot from the exterior. restrooms, hotel rooms, private offices. Best for privacy applications that still need emergency access from outside. Keyed entry locks from outside with a key and unlocks from inside with a thumb turn. This is the standard entry function, available in cylindrical board-in or mortise full pocket versions, and in commercial grade, grade 1 or 2, versus residential. Best for exterior doors where keyed access is required. A mortise lock set is a full lock body mortised into the door edge, recessed into a pocket cut into the door. Higher security and durability than a cylindrical lock, and it can house multiple functions: passage, privacy, entry, corridor, in one body. The standard for heavy commercial, institutional, and high-traffic doors. Best for high-security, high-traffic applications. Panic hardware, the crash bar, is required on life safety exit doors serving high-occupancy spaces. A touch bar or crossbar releases the latch when pressed. A UL-listed exit device activates anywhere along the bar. And, this is critical, it must not require a key to exit. The egress path always has to open from the inside with a simple push. Best for emergency exits and life safety door assemblies. A vertical rod device is panic hardware with rods extending to the floor and top of the frame in addition to the latch. Used on pairs of doors, double doors, without a center mullion. It's more complex, and the rods must clear floor thresholds and head stops. Best for double doors without a center mullion. A door closer is a hydraulic or pneumatic mechanism that controls the door's closing speed and latching. Required on rated doors, corridor doors, and many ADA path doors. It's surface-mounted, with a visible arm or concealed in the frame, and the closing force and speed are adjustable. Best for controlling door closing speed and latching. Electrified hardware is access control, an electric strike, an electromagnetic lock, a maglock, or electric latch retraction. It allows door release via card reader, keypad, or remote button, and requires coordination with the electrical and security systems. And here's a key safety distinction. Fail-safe versus fail-secure is a critical specification. Fail-safe unlocks on power loss, used where egress must always be possible. Fail-secure stays locked on power loss, used for security. Choosing the wrong one is a life safety problem. Best for access control and integrated security systems. At the bottom, the common finishes are noted by their numeric codes: 626 satin chrome, 630 satin stainless, and so on, and you specify finish along with function. The key takeaways: select hardware based on function, security level, and code. Confirm the door prep, backset, bore, strike, matches the hardware, and coordinate finishes, handing, and compatibility across all openings. And always verify the door schedule specs, the hardware function and grade, the handing, and the code and life safety requirements. Here's the structure of Participation Assignment 13. 5 skill stations, set up like a field exercise. Station 1. Door handing. Determine the hand, LH, RH, LVCHAR, or RHR, using the rule we drilled. Stand on the exterior, key side. Hinge side determines the hand. Reverse means swings toward you. Station 2. Frame throat size. Given the wall assembly, a 3 5/8 stud wall, a 6-inch stud wall, or a CMU wall, give the typical throat: 4 5/8, 6 5/8, or 8 5/8. Always verify against the wall type schedule and the actual wall thickness. Station 3. Hardware match bank. Match the hardware, passage set, privacy set, mortise lock, panic hardware, door closer, to its function. Station 4. Door type selection. For a school corridor, a storefront entry, a washdown or chemical area, and an office interior, pick the right door type. Your answers may include hollow metal, aluminum and glass, FRP, and wood solid core. Station 5. Corrective action. A door is out of plumb. Identify the likely issue from wrong hand, wrong throat size, hardware mismatch, or out of plumb, and state the error and the corrective action. The submission expectations. Complete all sections, use construction terminology, show clear reasoning, and write legibly and organize your responses. Think like the field on this one. Every door decision affects the next, so check fit, function, and code, and do it right the first time. It's on Canvas, due before today's deadline. Wrapping up. First, complete participation assignment 13, the door handing and frame worksheet, due before today's deadline. Second, quiz 10, doors, frames, and door hardware, opens today. And let me say this clearly, door handing is guaranteed on test 4. Practice the rule until it's automatic. Stand outside. Hinges left equals LH. In fact, that remember box is the single most important thing on this slide. The number 1 rule for door handing, stand outside, on the key side, facing the door. Hinges on your left equals left hand. Hinges on your right equals right hand. Practice it on every door you walk through between now and the test. Third, tomorrow is Class 14, Division 08 windows, glazing, and curtain wall. Storefront versus curtain wall, low-E glass, tempered, spandrel, and overhead doors, with glazing selection by use condition. And fourth, Thursday is Class 15, drywall, paint, stucco, and EFS, and weekly test 4 opens then, 70 to 75 questions, 2 attempts, due Sunday, June 21st, covering insulation, doors, windows, drywall, paint, stucco, and EFS. Your success checklist. Stay ahead of deadlines, complete the readings and assignments, practice door handing daily, and review the class materials and quizzes. That's Class 13, a big vocabulary day, so go back through the recording as many times as you need. Keep moving forward, and I'll see you in the next one for windows and glazing.